Let x0, x1, x2 be a sequence of numbers where each xk is either 0 or 1. For each positive integer n, define Sn equals the sum from k equals 0 to n minus 1 of xk2 to the k. Suppose 7Sn is congruent to 1 mod 2 to the n for all positive integers n. What is the value of the sum x 2019 plus 2x 2020 plus 4x 2021 plus 8x 2022? We can begin by inspecting the sum we are asked to find, specifically x 2019 plus 2x 2020 plus 4x 2021 plus 8x 2022. Note that the coefficient of the x's doubles each time from x 2019 to x 2022. 1, 2, 4, 8. This is similar to what happens in Sn, where from xk to xk plus 1, the coefficient doubles from 2 to the k to 2 to the k plus 1. We can force this sum, x 2019 plus 2x 2020 plus 4x 2021 plus 8x 2022, to appear more like Sn if we multiply it by 2 to the 2019. Multiplying the requested sum by 2 to the 2019 gives us 2 to the 2019, x 2019, plus 2 to the 2020, x 2020, plus 2 to the 2021, x 2021, plus 2 to the 2022, x 2022. This appears as a sum from part of S 2023. Specifically, it's the last 4 terms of S 2023. So it's just S 2023 minus S 2019. Everything up to 2 to the 2018 x 2018 is just S 2019. So it's just this expression equal to S 2023 minus S 2019. And what we are looking for is the value of this sum divided by 2 to the 2019. So we want S 2023 minus S 2019 over 2 to the 2019. We need to look at Sn more closely now. We know that 7Sn is congruent to 1 mod 2 to the n for all positive integers n. So we can say that 7Sn minus 1 over 2 to the n is an integer. Let's call it Tn. We know that Tn 2 to the n is equal to 7Sn minus 1, which means that Tn 2 to the n plus 1 over 7 is equal to Sn. But what else is Sn equal to? Well, it's equal to x0, 2 to the 0, plus x1, 2 to the first, plus all the way up to xn minus 1 times 2 to the n minus 1. And this is just shorthand for the binary number xn minus 1, xn minus 2, dot, 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 all the way down to x1, x0. This is a binary number with n digits, which is always less than 2 to the n. So it's clear that this sum does not exceed 2 to the n. Since Sn is less than 2 to the n, the maximum possible value for 7Sn is equal to 7 times 2 to the n. It's less than 7 times 2 to the n. And 7Sn is equal to Tn 2 to the n plus 1. And since that's less than 7 times 2 to the n, it means Tn times 2 to the n plus 1 can be at most 6 times 2 to the n plus 1. So that means Tn is at most 6. It's less than or equal to 6. Tn is also greater than or equal to 1 because it can't be 0. Then 2 to the n times Tn plus 1 would not be a multiple of 7 if Tn is 0. It would just be 1 over 7. So it follows that 1 is less than or equal to Tn is less than or equal to 6 for all positive integers n. And this is sufficient to determine a unique Tn for all n between 1 and 6 inclusive, such that Tn 2 to the n plus 1 over 7 is an integer. Or Tn 2 to the n is congruent to negative 1 mod 7, which is congruent to 6 mod 7. Remember, we want S 2023 minus S 2019 over 2 to the 2019, which is simply equal to T 2023 times 2 to the 2023 plus 1 over 7 minus T 2019, 2 to the 2019 plus 1 over 7, all divided by 2 to the 2019. So that's just T 2023, 2 to the 2023, plus 1 minus T 2019, 2 to the 2019 plus 1 over 7 times 2 to the 2019. You can cancel out the plus 1s, and then you can cancel out the 2 to the 2019 leaving a 2 to the 4th here, 16. And so we just want 16 t 2023 minus t 2019 over 7. That is what we're looking for. So this is the simplified version of a problem, and we would like to find 16t 2023 minus t 2019 over 7. This is all from what we have found in the past. It would be useful to consider powers of 2 mod 7 and their cycles. So first, 2 to the 0 is equal to 1, which is congruent to 1 mod 7. Then 2 to the 1 is congruent to 2 mod 7. And 2 squared is congruent to 4 mod 7. And this repeats after 2 cubed, which is 8, that's congruent to 1 mod 7 again. So it repeats in groups of 3, and 2023 is congruent to 1 mod 3, while 2019 is a multiple of 3. It's 3 times 673, so it's congruent to 0 mod 3. So we only need to consider the case where n is congruent to 0 and 1 mod 3. In the 0 case, the Tn we want, which is between 1 and 6 inclusive, such that Tn times 2 to the n is congruent to 6 mod 7, is equal to 6. Because 1 times 6 is equal to 6, which is congruent to 6 or negative 1 mod 7. And all powers of 2, where the exponent is congruent to 0 mod 3, are congruent to 1 mod 7. 2 to the 0, 2 cubed, 2 to the 6 are all congruent to 1 mod 7, so Tn is 6 for all of them. Similarly, in the case of n being congruent to 1 mod 3, then we have Tn is equal to 3, because 2 times 3 is equal to 6. So t 2023 is just 3, because 2023 is congruent to 1 mod 3. And t 2019 is equal to 6. Okay, and we want 16 t 2023 minus t 2019 over 7, which is just equal to 16 times 3 minus 6 over 7. That's 48 minus 6 over 7, which is 42 over 7, and that's equal to 6. Going back to the problem above, we hope that 6 is in our answer choices, and indeed it is. That's answer choice A, and we are done. Thank you for watching this YouTube video, and please follow my channel if you would like to see more videos.